Hi, I think we can start already. So, yeah, my name is Wojciech, and I work for SoftwareMention for 4 years, mainly React and React Native developer here. And I have a pleasure to be a host today. It's my first time speaking in English to people, so don't mind me if I get stuck or something. I'm really nervous. So, yeah, I get the pleasure to show you the news from the React and React Native world. And then we have two wonderful presentations from my colleague from SoftwareMention. First will be from Alek about URL-based navigation in React Native, his own library he created. And the second one will be from Wojciech, introduction to react-native-svg he's already working on. But first, the news, and that's a lot of them. I have to tell you one thing. We as a React developers have been spoiled a couple last week. So the Facebook, or I have to say Meta, the creator of React and React Native did a really great amount of work to create the tools that they released this week. So thank you, Meta. You did good. And let's see what's the meal. And the meal today is the React 18 that was actually released on the March 29, 2022. And the very next day, they announced the React Native 68. And it's a lot to cope with. So let's get started. First, the React 18. It brings some super cool features like the concurrent mode, or how they wanted to call it, concurrent features. And it's a set of features. It's going to help us have more fluid and responsive UIs. And it will try to achieve that by overcoming limitations of JS being single-threaded. And it sets tools. For example, the suspense. And the suspense is, as it's read data over the network as easily as props or state. So it gives us the way to create a simple component for fallbacks, so we don't have to wonder about the loading states, the activity indicators in some complicated way right now, like we do it with the props or variables that we set like is loading. It's gonna be more easier than that. We don't have to care about loading states anymore. If something is not loaded inside the suspense, it will just create the loading state. If it's ready, we'll show it to us. And the next thing I'm really amazed about is automatic batching. And batching is when React groups a multiple state components, multiple state updates into a single re-render. So if you create a couple of set timeouts, now in React before 18, it will create the single re-render for every single use interval, use timeout, use anything. Right now, the React will realize that multiple things happening at once, and we will do only one re-render for a better performance for us. And now let's look what React Native 68 brings us. And it's more of the feature that it brings, it's more like the glimpse into the future, how the React Native architecture will look like in the future. So yeah, wear your helmets, go into my car, and we are going to the future. And the new future is the new architecture, and it's amazing. We got a lot of problems with React Native right now, like it's fully asynchronous, and we have a lot of problems with the bridge. So in Facebook, they decided that we need a new architecture to overcome those obstacles. And this is it. This is the new architecture. We only have a glimpse right now. It's not fully ready, but we have the architecture overview that will give us a lot of information how it works. We have a migration guide, so we can check it out for ourselves. And most important, the library contributors and owners can already go into Fabric, go into the new architecture to make it work. So we have libraries and stuff, because right now they are broken, they don't work with the new architecture. And with it comes the Fabric, the new rendering system that is going to replace the current one. It's going to be faster, more reliable, and we're gonna have a way to measure the components on the go, for example. And here, I am proud to announce that software mention libraries are all under constructions, reanimated, gesture handlers, screens, all will be able to go together with Fabric as soon as possible. As far as I know, the gesture handler and screens are already ready. You have to mention about the turbo modules as well, because that will work with Fabric to create much smoother and faster experience in React Natives in the future as well. But React 68 is just the beginning. It's the first step to the new architecture, and it got some downsides, like there's not React 18 yet. So that means no concurrent mode yet, no suspense, no automatic batching. We need the new architecture to be ready to use it in the React Native stuff. But it was already a week. And I have to tell you one thing. The thing I anticipated the most, and I've been waiting for a super long time, actually didn't come from the Facebook. It came from the software mention, and more exact from software mention reanimated team. And it's the React Native reanimated new hook, use animated sensor. So if you take your phone and move it around, you will be able to sense those gestures and animate them. So if you do something like this, or like this, or even like this, React Native can recognize those gestures and animate them. So it can even work for normal gestures too. But I can't wait to encourage people to create totally useless features just because we can. And for the last thing, I really wanted to announce that Software Mention, together with Expo, is hosting the conference, App.js conference, here in Krakow, 8 to 10 June 2022. And there are still places you can still book your spot. So I really encourage you to check it out, because it was a great experience. For the first time I've been on the App.js conference. And the last thing is that the fame and glory awaits, because all of you can be speakers on the next React Native community meeting. Yeah, and not only fame and glory awaits, there's also flip-flops, there are hoodies, there are some gadgets that Software Mention can provide, and flip-flops. Yeah, the best. So yeah, that was really the fast gathering of what's the best, in my opinion, from the last weeks in the React and the React Native community. And right now I want to invite Alek to tell us more about his new navigation library.
Works. Can you guys hear me on? Oh yeah, you can hear me. Cool. You gonna switch for me? Oh, so nice. Thanks. That's done. Yeah, it takes a bit to set up, but yeah, it should be it. You're doing it right, no worries. It might be like, maybe that's, yeah, I'll do it my way. Your pesto's not good enough. Just kidding. Yeah, now we can click on. Yeah, except I now can't see it on my screen. One second, guys, sorry. Yeah, play. It's gonna work any moment now. Oh, yeah, now it works. Cool. So, hello guys, I'm Alek. I've been here for almost 4 years, and I've started with React, and then I transitioned to more of React Native role. So this is why kind of this library exists, and I want to tell you a bit more about how those concepts from the web can map out into the React Native ecosystem, and hopefully in the future create something or make something that would be an alternative for React navigation for some apps, obviously not for all, but hopefully there's a way to do certain niches or certain needs if you create a bit of a custom app more approachable without doing those complex React navigation stuff. So all right, let me tell you first a bit more about how it works on the web, just in case I know you're all probably quite familiar with this, but I can I think of the web navigation as there's like a single element of state. There's like the URL bar, and you need to do all the UI yourself. But in turn, you get this really nice abstraction of thinking about state. Like a majority of your state for the app can come from a single string. So then if you do your app correctly, people can just share a link to a certain page to their friends, and it just works out of the box. And the configuration is a bit more complex than what you have in React navigation, perhaps, because now you have to think of the URL structure, and you just can't really do anything you want. But in turn, you get this really nice abstraction that works in all browsers, is kind of managed by the system, and then you just provide some custom UI for it, and it just works. Which is totally different to the way we do native mobile navigation currently. Mostly because the UI on native is way more complex. So you have those stack navigators, you have those tab navigators, and if you want to use just a URL for it, you will quickly find out that it's not really enough. So you need to kind of support those quite complex UI interactions, because you have less space on the device. You need to show a lot more screens, and you just need to kind of handle all those patterns. So yeah, just to compare, here's like React navigation. You'll know it, you'll love it. You just create some screens, you name them, and you provide components for it. And you can define those stack navigators and tabs, which really makes for 90% of the UI you will need. And in turn, here you have React Router, which is like the default option on the web. I think they said that downloads of React Router amount to like, I guess, more than 60% of downloads of React. So it's like a real popular library, and everybody uses it, especially now with Remix. This is what the guys that did React Router are now working on. You have this set of very new, very cool abstractions that you can use. Yeah, this seems to be shaping out as like the default way to do navigation in single page apps in React. So this is definitely something to like be familiar with if you're doing anything on the web. But it's totally useless on mobile. There's like a mobile version, but it just copies the code from React Router on the mobile, and you have none of those abstractions. You don't have tabs, you don't have stack. It's just like if you open the web page on mobile. So that's not good enough. So now we can kind of compare those two approaches. So for the web routing that's on the left, you get this kind of simple idea that the browser just handles state for you. Like you have undo buttons on the browser, there's like some system UI for it, and it's a very simple state. In the basic form is just, it's like a list of strings, and you can go back and forward. Yeah, some of those actions are provided by the browser, so you can kind of press to go back or swipe or do anything. But if you want any UI, you need to build it out just of primitive components like divs, and you don't have like a really nice system supported way to do it. And if you try to build a mobile app with those kind of small screen estate, a lot of those kind of native behaviors, you'll find out that you just can't describe it in like a history correct way. So there's no like, one good example is that if you use Instagram and you click through some of the tabs, your history gets preserved on each of the tabs separately. And it just doesn't happen when you try to do it on web. There's like no way. You need to keep it in your custom state, and you need to think of it manually. And just that sucks. And undo also doesn't do what you want. If you undo, you want to work on you want it to happen on the tab that you have selected, and you want it to undo all the state on the tab, but it's only really does like the system, it really only undoes the system action. So if you change tabs recently, it will just, on the web, it will go back to the different tab. It's just totally a different abstraction. In turn, on React navigation, you don't have all the nice things on the web. So yeah, the state is super custom. It's perfect for native like navigation patterns, and it integrates perfectly with native components like React Native screens that we do here. Shout out to the open source team. This library is just riding on the shoulders of giants. Yeah, but then if you want to do deep linking, so you want the same URLs to work on the web and on mobile, again, you need to create a custom config object, you need to do it manually, and even though React Navigation claims to kind of support it, it's not really supported by default. You need to define like a mapping from URLs to the navigation state. And for me, React Navigation, and this isn't just the thing I've talked to several people that kind of shared it, is that it becomes quite complex. And it's like a very powerful tool that becomes difficult to use when you need to do some custom stuff. And then you do some weird stuff like pushing some reset actions on top of a stack, and it's just confusing. So I was hoping there would be a way to make a better abstraction that would provide really sensible defaults. So yeah, what do we want to build out? We want to build out something that uses just a single URL as a primary source of truth. So if you need to kind of see what screen is focused on right now, or if you need to do like a navigation action, you just open URL. There's no like push screen to stack. You don't really think of it in terms of where do we want the screen to open. We just open URL. And the state is very simple, but it allows you to express anything you kind of need by default on a mobile device, like separate history in different tabs. Yeah, I want to use React Native screens. I don't want to do it myself. And the other assumption was that it's a superset of React Router. So I was hoping that at some point we could write a single piece of code, and it would work on the web, and it would kind of render out a UI that would make sense for the web. And on mobile, you would just replace some kind of key components with either stack or tabs, and it would just map the structure of your app on the web to a reasonable structure on mobile. So for like basic apps, it should just be a kind of no config, just take your React Router structure, change some components, and it works. Yeah, on the web, you don't really have any use for the stuff that this library does. So you just need to compile it away, because you don't need like React Native screens on the web. You just need React Router. It's like the best library out there. Yeah, okay, so we need two pieces. The first is like the React Router integration combining with the native navigators. This is kind of like the missing piece of React Router native in its current form. And the second is like a different way of thinking of history. It's no longer a list of URLs. So let me show you how this looks. I was kind of thinking that maybe we can go away from like a single list and instead move to a tree structure. So here we can see like a sample URL, and we can divide it into segments just by taking the slashes. And then for each kind of prefix, which is a list of one or a few of the segments, the initial segments, we store a list of the kind of any word after the last slash that has been visited. It's a bit hard and confusing, but this essentially maps a way of thinking of URLs to the mobile, more like mobile way of thinking of actions on screens. If you do undo, it just does it from the end, so it undoes on the tab that you have visited recently. It doesn't switch tabs. And this abstraction is actually really powerful, and I feel like it provides a lot of kind of sensible defaults just by this definition. Yeah, and for now those are strings, but they can really be anything. So I was thinking of just dumping the location objects from React Router into there. If some of you guys program in web and in React Router, you might be familiar. It's just like a URL plus some state plus query params plus really a key. So you can really store anything you need in terms of arbitrary state objects in this kind of in this tree. Yeah, and this allows us to do some stuff that doesn't work out of the box on the web. So on the web, you can't really have two different histories in two different tabs. You can't really do like a split pane layout. And with this, it's just like two different objects on this tree. And you can essentially do different tabs, and the tabs can have different history, and you can do models, and you can do all the nice stuff that works with React navigation, hopefully. But this is all hidden. Like, you don't need it unless you're doing something weird. For like a majority of use cases, you should just be able to define your structure and use URLs to navigate. So deep linking also should kind of work out of the box, because you can just say that, oh, when you open a deep link, it just navigates to the correct, to this URL. Yeah, and if you need to render something in the background, like not on the primary layer, so like screens that are not focused right now, area behind the model, you can just use the full nested history object, and the navigators I provide kind of do that for you. Yeah, so how to implement this? Yeah, you just kind of, instead of wrapping with like a browser router from React Router, you use just a custom router I wrote. You replace the routes component in React Router with a navigator, one of the two, either a tab or a stack. And the API should feel very familiar. It should be just React Router with some sprinkles on top. Yeah, so this is, on the left here you see a React Router code. On the right you see React Native URL Router, which is like a super temporary name I gave for it. We'll probably change it to something better, we'll see. Yeah, instead of just having like two different screens that can show up, it's either like a root screen or invoices. Here you have two different screens on a stack that get pushed or popped depending on the URL kept in the native router. Yeah, and I have a quick demo that hopefully the video will work. Just like a super basic app that I've written with it. So you have like two tabs, a stack navigator in each of those, and you can have a model. And this model can have like a nested stack. Yeah, so hopefully it should work out of the box for like those simple apps. Yeah, so where we're at and what I want to do with this. So this all kind of started when we got approached about writing a native version of React Router. Since then, it's kind of pivoted into still the same thing, but hopefully a library that is like a simpler React navigation. We got approached by one guy who said that, oh, React navigation is quite complicated, and it might be possible to do something quite simpler. And this has like not that much code. It's so hopefully for like a basic app, this should suffice. Yeah, where I'm at. So we've got like a tab navigator, just using call stack's view pager. We got a stack navigator from React Native screens, and we got support for all of the stuff that we kind of get for free from React Router. So deep linking, path params, query params were a bit of work, but we got them in. And yeah, just some documentation and some examples, so it's like super early. Now I want to add support for those arbitrary state objects on URLs, so I need to move this to a location interface. And I want to make a more defined way to make models. Just so you can say that, oh, here's like a layer, and this model can have its super separate history. Yeah, and then hopefully at some point we'll use this in production apps. But I wouldn't really recommend it right now. This is more a story of how you can kind of think about web and React navigation, and how possibly we could merge this at some point. Hopefully, in like 3 months, we'll be confident enough to use it in like a full-fledged production. But for now, if you would be willing to play with this, or try it out, or use it in like a small app that then you can quickly migrate away to React navigation if something doesn't work, then I'm here to provide support. So yeah, if you would like to check it out, it's on the GitHub of Software Dimensional Labs. Yeah, and you can always hit me on Twitter. There's even some documentation, so it should be like clear out of the box, but I'm there to kind of help you navigate and try out this example. Yeah, and here's a funny meme because I was envious of Wojtek. Yeah, so thanks.
1, 2, 3, 1, 2, 3. All is working. Okay. Where's the mouse here?
Really need a better setup for this.
It's like. Can I get it there? Do you see? Or no? But I cannot move this. Not this. How to do that? Okay. Oh. Yeah, you're the programmer here. Okay.
Does the work?
How many doctors do you need to do this? Okay. Okay, so I should move this here now.
Yeah.
And
Good job.
whoa. Okay. Okay, that was my presentation. Okay. All is good. It's not my phone. Okay. So hi, I'm Wojciech Lewicki. I work here at Software Mention in React Native open source team, and I would like to introduce you to react-native-svg today. So maybe let's start with some background. react-native-svg is one of the eldest libraries of React Native, dating back to 2015. And as some of you may know, it has been quite abandoned for more than a year now. And ever since the main contributor, Michael Sand, posted that the repo is looking for maintainers, there wasn't much traffic there. So here are some statistics about the repo. The library has more than 500,000 weekly downloads, whereas the React Native has about 800,000 downloads a week. So it is about 2/3 of the whole projects. So it is quite a significant number. And it has about 6,000 stars right now. And in the moment I was making this presentation, there were 269 issues and 45 PRs opened. So it's quite a significant number too. And this is the result of the abandonment. And this area is something for sure to be worked on. So we, as Software Mention open source team, recently decided to help with the maintenance. So we started with merging some crucial, long-standing PRs that could even make the library stop working anytime soon, because one of them was removing JCenter from Android. As some of you may know, it is shutting down, so it would just not work then. And we also added support for some new things from React Native, like platform color. And we had to do this because it needs to be handled in a custom way in React Native SVG. And one of the problems that quickly arose was navigating through the code to see why certain things are implemented in such a way. And to understand it, we had to go through some discussions in the PRs and the issues. And it is because any of the previous maintainers is active, so we cannot just contact to them easily. But we are getting better and better at it, so it should be fine, and it's not such a big of problem now. Okay, and I will try to quickly introduce you to the basic concept of SVG, which is scalable vector graphics. The standard comes from web and is an alternative to using other graphic formats as PNG or JPEG. And some of the advantages over other image formats are not losing quality when zoomed or resized, being written purely in XML, and being able to be searched, indexed, scripted, compressed, etc. So as we can see on the screenshot, we can either choose to have different sizes of each image in a form of PNG or JPEG, or use one powerful SVG to rule them all, and it is nice. So, okay, let's move to the elements provided by the standard. Basic shapes are rather self-explanatory. First one is circle. Its extension is an ellipse. Then we have a line which has a starting and an ending point. Next one is polyline, being concatenation of many lines, and something similar to this is a polygon, but its first point is at the same time its ending point, so we just create closed shapes. And the last one is a rect, which is a simple rectangle with a possibility to round its corners. And a big part of the standard is handling text elements. It also takes a good part of the implementation in react-native-svg, both on the JS and the native side, due to the necessity of handling its whole specification with the methods exported on each platform. So here we have a text. It's a basic graphic component containing text with all the props of the SVG that can be applicable to it, such as gradients, masks, clipping, etc. Then we can have a text path, which renders the text alongside the path that is specified. And the last one is tspan. It's a subtext within a text component, so we can use it to style one letter, for example, in a custom way. Okay, and let's quickly dive to the most crucial structural elements. The first one is SVG, being the root of the component tree, and introducing the coordinate system to its children via the viewbox prop. And let me shortly explain the code. The SVG element introduces 300 units of width and 100 units of height for the children via its viewbox. And each of the children must use values relative to this in their own sizes. So the first circle will start at 50 units, and the second one will start at 150 units of width. And both circles will start at 50 units of height, but since the 100 is available, they will be rendered in the middle of the SVG view height. Okay, another important element is use, which clones elements defined in different parts of the SVG. The base element must provide ID. Here is a circle, and it then must be applied to href prop of use element to clone it. We can also change some of the cloned element options, as seen with different fill values in the code example, because the black fill is the default one, and the cloned elements have each blue and white fills. Another one is def tag, and it's a brother of use, defining reusable elements which are not rendered by themselves, but can be shown with use tag. Quite analogous to the previous example, we define a circle and linear gradient and give them unique IDs. As those elements are covered with def tag, they won't be rendered, but can be used somewhere else. We then take the use element and apply both those options, resulting in this pretty circle shown on the slide. The last of the most important structural elements is G. It's the shortcut for the group. It is used to concatenate multiple elements. Transformations passed to the G element are performed on its children, so it helps with composition of those components. And in the code example, props from G are applied to its children circles, so they have both a blue fill and 5 with green stroke around them. Okay, and let's now talk about React Native implementation and why it is used in client applications. The quick answer is I have no idea, since I worked at open source, not in client projects. But to be serious, vector graphics are like present in almost every project, since it is often the standard for designers to make UI elements with this. And due to the benefits discussed earlier, like not losing quality on different displays, and they are also safer and easier to test throughout many phones. Another one is the phones tend to have zoom-in gesture, and so being able to provide that zoomable graphic for e.g. the company logo is something very important in this case. Okay, and it's time to dive into the parts of the implementation and see what we can achieve with it. So we'll start with JS. And I think it is important to know how to render SVG elements in context of their capabilities. if we want our own custom shapes written by us, we can just use components provided by the library, and you can find almost every component from the SVG standard there. And the biggest benefit of this option is being able to attach the state to each of those components. So, for example, if you want to attach gesture handlers or animations to them, it can be done. So the GIF here shows the SVG circle with gesture handler and reanimated attached. And we can change its position and color in 60 FPS or even in 120, depends on the phone. Okay, and the other option is having static SVG components, which are parsed under the hood to the React component hierarchy, and we don't have then access to this hierarchy. First of them, SVG XML, is to include an XML in a form of a string, similar to how it's done in embedding SVGs on the HTML on the web pages. And if the XML is not local, we can use SVG URI component to fetch it from web. And the task of parsing the HTML lies on the library. If CSS styles are included in the XML, you should use SVG CSS. Another option is using files with SVG extension. They can be parsed in two ways. We can use react-native-svg transformer library, which adds a Babel plugin and uses it when the JS is bundled. It takes the SVG files and then transfers them into component hierarchy. And another slower option is using local SVG component, which is doing the same but in runtime, not when bundling. Okay, the library has very complicated props parsing code base, I think dating back to the beginnings of the library, and they are called extractors. For example, to calculate the transformation of element, the extract transform is used. It is required due to the custom format of many props in SVG. Like you can use the color named current color, which is not a color from React Native, but it is a part of standard of SVG and is interpreted in some way. So, to be honest, I've read the extractors code many times, and I still don't understand most of it. So my approach is something I've learned throughout the coding experience, that if it works, don't touch it. So it's okay most of the time. But the problematic part of this is animating props, e.g. with reanimated, because it expects the direct mapping of prop names to the native side and changes them without the interaction with JS. So the extractors from SVG won't be triggered on them if we do it with reanimated. So it means that we need some hacky solutions just to prepare the values for it. And we saw the GIF with animated circle some slides ago, and I warn you that it wasn't so easy to implement it like it looked like, so be careful. Okay, and let's now jump to implementation on iOS, macOS, and Android. Okay, on Android, we draw SVGs with bitmap and canvas objects. They are the components used for drawing views on Android, and by default, they are handled internally by instances of view, and just draw the contents of it. And the library uses SVG view object at the top of the hierarchy and hijacks the onDraw method, which is called when the view instance is asked to be drawn. And the onDraw method provides canvas, which can be filled with a bitmap object. Such bitmap is created in SVG view and passed to its children, letting them draw their part on it. And since we don't want to calculate all of the operations each time the onDraw is called, which is very often, by the way, we check if something changed in the children, and if not, we just return the same bitmap each time the onDraw is called. But otherwise, if something changed, the bitmap is recycled, nulled, and all the calculations are made again. And all of the drawable elements implement their own getPath method, and it is returning how the element should look like on the bitmap. We use Android's native path class methods like addCircle, addPath to draw the exact shapes. And on iOS and macOS, the process is quite analogous. We draw on CG context in draw-rect method called by the system on the view. In case of changes in the SVG hierarchy, the invalidation consists of calling platform's native setNeedsDisplay method, which in turn calls draw-rect again in the next frame. And each drawable component returns the part of its drawing in the getPath method, just like on Android. And there's interesting part, since library supports both iOS and macOS, we need to do some tricks to make it work on both platforms because, as you may know, there's no UI kit on macOS. So it means that we cannot use UI view there because we need to use NS view. We can use UI color because we need to use NS color, etc. And it is based on the build target. So it is done in the library with some very intelligent macros. And it works pretty well most of the times. It just doesn't work when the exact view has a different method for each of the platforms. But most of the time, it's okay. Okay, and the last thing I wanted to mention is our plans for the future of react-native-svg. And I am currently working on Fabric integration there. And it is for sure going to take some time to be finished. But we as open source team already have much experience with the process since we already ported React-Native screens and React-Native gesture handler to Fabric. And we continue to make it more and more stable each day. And hopefully React-Native Reanimated is going to join those two soon. Our team is working pretty hard on it, so stay tuned. And at the same time, we are trying to detect and remove memory leaks, which happen quite frequently on iOS. And it hopefully will lead to lower memory usage and better performance of the library, which is a culprit. Okay, and I think that's all. Thanks for the listening, and if you have any questions, feel free to ask them now. Thank you.
So I have one question. Could you explain what is the difference between...
Take the mic.
Okay, it's work. I have one question. Could you explain what is the difference between React Native SVG and React Native Skia?
Okay. I've read some of the code base of React Native Skia. If you don't know what it is, it's like the new library from Shopify that implements the same concepts, I think, as SVG, part of them. And concerning SVGs, Skia uses the Google's native API written in C++ for parsing the SVGs and drawing them. So since it's C++, we get both platforms at the same time, and it should be faster than any other option. So it's definitely a good thing. The bad thing is that it doesn't work currently too good because it's still in alpha. I haven't tested it, so yeah. So I think that in some time in the future, it may be possible that the React Native Skia will just overthrow the React Native SVG. But there are some cases that I think still the SVG is better for drawing, like maybe with, I don't want to say some stupid things, but I think with animations, maybe and gesture handling is better with the current solutions in React Native, and the Skia is not implementing it very well now. But there are, like, I think we should first just use the library, the Skia library, before we can just dive into it more deeply, because it's not ready now, so it's like not, I cannot relate too much for now. Okay, if none of you has any more questions, I think we can end. So Wojciech, take the lead.
Yeah, so hi one more time. I think that's it for the moment. I really encourage you to stay with us and grab a beer, have a talk, and there will be pizza in about 5 minutes, so yeah. 10. I get a sign. So yeah, it was really nice having you here today, and those talks were really amazing. So yeah, hope to meet you on the next React Native community. I hope next month in May. So yeah, thank you very much, and see you soon.